Hi everybody, Miss Sarah here. Today we're going to start our Unit 3, which is going to be about functions, general idea about what a function is, how it works, etc. So we're going to start off with Lesson 1 today about relations and functions. Okay, so before we understand what a function is, we have to understand what a relation is, and it's pretty simple, okay? Whenever you have two different variables that are related to each other, we have a relation, all right? So for example, a person's arm span versus their height. There is a relation between a person's arm span and their height. If we were to measure each of yours arm span and height, which we could do if we were in class, we could create a scatter plot, right, where we would have height as a function of your arm span. And you can see that although it's not necessarily linear, right, it's not completely like perfectly related to each other. You can have someone a little bit taller with someone with a shorter arm span or vice versa. In general, what we see is that there's a line of tendency, right, where the taller the person is, the bigger the height, the bigger the arm span of the person. So these two variables, they are related to each other. And a relation, the exact definition of a relation is nothing more than a set of ordered pairs. So if you take a look over here at our graph, you're going to see that each person that we measured is going to have an ordered pair. This represents a relation, right? So this person has a height of 150 centimeters and I don't know, this is about 100 centimeters maybe. This person over here is going to have a height of, I don't know, about 189 centimeters and an arm span of about 193 centimeters, and so on and so forth. So an ordered pair represents a relation. It relates, in this case, the height of the person to the arm span of the person. In a relation, remember, a relation is nothing more than a set of ordered pairs. We call the domain of a relation all of the x values and the range of this relation all of the y values. So for example, if I have this relation over here, I have 3, 5, negative 1, 3, 4, 8, 3, negative 7. The domain, if I asked you to find what is the domain and range of this example over here, it's pretty simple. The domain is going to be all the x values. So you can see that the x values are going to be 3, negative 1, 4, and 3. And the range is going to be all the y values, 5, 3, 8, negative 7. So this is going to be my range, and this right here would be my domain. So this is the first page of the PDF packet you guys got, and this is supposed to help you visualize the different ways that we can represent relations. So we can represent relations as ordered pairs, as a table, using mapping or graphing it, all right? Once again, the definition of a relation is a set of ordered pairs. The set of x values is called the domain, and the set of y values is called the range. So let's take a look at number 1 first. Number 1, I gave you the ordered pairs, and then I asked you to give me the domain and range. This is pretty straightforward. The domain would be all of the possible x values, but there are a few things you have to be careful with when writing the domain of a function or writing the domain of a relation. The first one would be to use set notation, which are these squiggly parentheses over here. Second thing is you have to write the x values in order from smallest to greatest. All right, so that's the first thing you have to pay attention to, is it has to be from least to greatest. Okay? Not only that, but the domain, people, it represents all of the x values the function contains. So notice that in this relation over here, I have a negative 3 and a negative 3. So I don't have to repeat the negative 3, because if I'm asking you for the domain, I'm asking you which values of x are included in this relation. And if you tell me that negative 3 is included, then negative 3 is included. You don't have to say negative 3 is included and negative 3 is included again, okay? Because I'm just asking you which values are included. So you do not, the second thing that you have to remember about domain and range is you do not repeat values, okay? You do not repeat values in domain and range. Of course, in the ordered pairs, you repeat the value. In the table, you repeat the value. In the graph, you repeat the value. But in domain and range, you do not, okay? So let's write this from smallest to greatest. Between negative 3, negative 2, 1, 3, and negative 3, the smallest number we have is a negative 3. After that, negative 2, 1, and positive 3. Range, same idea. So let's take a look at the y values. We have 1, 0, 2, negative 4, and 5. In this case, nobody repeats. Our smallest one would be negative 4, 0, 1, 2, and 5. So we got our domain and range for this relation. I sometimes say function, but right now we're only studying relations, so it's all relations. Putting it into a table is very easy. All you have to do is get each ordered pair. Remember, each of these ordered pair represents an x and a y coordinate, okay? So all I have to do is write the x coordinate that's related to the y coordinate. So I have the coordinate negative 3, 1, negative 2, 0. If you don't know where I'm getting this from, negative 3, 1 over here, negative 2, 0 over here, then 1, 2, 3, negative 4, negative 3, 5. This is super simple, just copying it down. Mapping is, I'm not sure if you guys have seen mapping before, but mapping is very commonly used in problems involving relations and functions. In a mapping diagram, what we do is we have to draw two circles, two bubbles, or two ovals, all right? This first bubble over here is going to represent your domain. And the second bubble to the right is going to represent your range. And then what you're going to do is you're literally going to copy the domain over here. So we have negative 3, negative 2, 1, and 3. And for our range over here, we have negative 4, 0, 1, 2, 5. And you write it like this vertically, all right, from smallest to greatest. And then you're going to draw arrows from the domain to the range. But you do not draw a bunch of arrows like that. People, if you do that on the test, you automatically get a 0 for the question. What you have to do is you have to show the relation. This is what this unit is about, relations, right? Between the domain values and the range values. In order to know the relation, you can go back to your ordered pair or back to your table and see how they are related to each other. Negative 3 is related to 1. So let's draw an arrow from negative 3 to 1. Negative 2 is related to 0. So we draw an arrow from negative 2 to 0. 1 is related to 2. So we draw an arrow from 1 to 2. 3 is related to negative 4. And we have negative 3 related to 5, but we already had negative 3 over here. That's okay. You can draw another arrow, leaving negative 3 and moving all the way to 5. All right? And finally, we can graph this. You can use either the ordered pairs or the table for graphing. I'm going to use the table in this case. So I'm going to have the point negative 3, 1. All I have to do is go left, negative 3, x, negative 3, y, 1. Then I'm going to have negative 2, 0, 1, positive 2, 3, 1, 2, 3, negative 4, and negative 3 once again, positive 5. 1, 2, 3, 4, 5. I want you guys to try to do number 2 now on your own and upload it to Schoology in the appropriate place. Moving on to number 3. Number 3, I didn't give you the ordered pairs, but I did give you the graph. So we're going to have to go backwards in number 3, and this is pretty simple as well. All you have to do is figure out the ordered pairs. So this one over here, this has an x value of 1, 2, 3, 4, x4, y2. This one over here is going to be -2, 3. This one is going to be 0, -3. And this one, 2. So it's 2, 1, 2, 3, 4, 5, 2, -5. And this one's going to be 1, 2, 3, 4, 5, 1, 2, 3, 4. So it's going to be -5, -4. So I can get these ordered pairs over here and just rewrite them. On this side, I'm going to have -2, 3, 4, 2, 0, -3, 2, -5, and -5, -4. Okay, I rewrote it nicely now. And don't forget that these ordered pairs, they also have to be closed by brackets, curly brackets, all right? Now let's go ahead and find the domain and range. The domain is all the x values, so I'm going to highlight the x values over here. The smallest x value that we have is -5, followed by -2, 0, 2, and 4. The range is going to be 3, 2, -3, -5, -4. So the smallest range, the smallest y value is going to be -5, -4, -3, 2, and 3. Translating this into a table, I can simply copy the ordered pairs, -2, 3, 4, 2, 0, -3, 2, -5, -5, -4. For mapping, I have to use my domain and the range that was given to me, that I figured it out over here. So this is going to be, my domain is -5, -2, 0, 2, and 4. And my range is going to be -5, -4, -3, 2, and 3. Now we have to find the relation between them. So we have that, in this case, -2 is related to 3. So -2 is related to +3. -2 related to 3. 4 related to 2. 4 is related to 2. 0 is related to -3. 0 related to -3. 2 related to -5, so 2 to -5. And -5 to -4.